Hi everybody. In this video we are going to continue with the topic called as post-fertilization events. Post-fertilization events. And in the previous video we already studied the first one. Okay, we already studied the first one. Now we are going to discuss about the embryo formation. Okay, how the embryo will be formed. In the first one we studied about endosperm formation. Endosperm formation as the first post-fertilization event. And the second event which we are going to discuss today is embryo formation. Embryo formation. So let us make it very clear to understand how this embryo formation will be taking place. So you have seen the diagrams how the embryo will be formed. How the embryo will be formed. So here these diagrams are indicating how the complete embryo will be formed, showing the main parts of the embryo. Okay, mature embryo. This is the mature embryo which is showing all the important parts that should be there. That should be there here. Like it will be having plumule, it will be having cotyledons, it will be having the radicle and also the suspensor. These are the major parts we say in a mature embryo. But this embryo will be developing from what? It is from the fertilized egg, that we are calling it as what? Zygote. That we are calling it as zygote. So here, embryo formation. Embryo formation we are talking about. So here, the first word that we have to keep in mind is embryogeny. The first word that we have to keep in mind is embryogeny. Okay, embryogeny. Okay, so here, so what is embryogeny? What is embryogeny? The process of formation of mature embryo. The process of formation of mature embryo from a fertilized egg. From a fertilized egg is called as embryogeny. Embryogeny. So what is embryogeny? It is the process of formation of mature embryo. It is the process of formation of mature embryo from what? From the fertilized egg. That is called as what? From the zygote. Okay, from the zygote. So this we are calling it as what now? Embryogeny. The process of formation of mature embryo from the zygote is called as embryogeny. Embryogeny. Now, how this process is taking place? How this process is taking place? We are looking at it in a schematic way. Okay, we are going to study it in a schematic way, diagrammatic form. So here we said mature embryo. How it is formed? It is from the zygote. Now here it is this zygote. It is this zygote which develops into a mature embryo, we are saying. So zygote, first point that we have to keep in mind is that zygote is a diploid cell. Zygote is a diploid cell. Zygote is a diploid cell. Where is this zygote present? It is present in the ovule. Where is it present? It is present in the ovule. And inside, where inside the ovule it is present? We said it is in the embryo sac. It is in the embryo sac. Say suppose when we have seen, okay, when we have seen an ovule, okay, when we have seen the ovule like this, okay, when we have seen the ovule like this, now it is this region. And we say that here, what is there present here? This is the embryo sac. This is the embryo sac, we said. So inside the embryo sac, exactly at what point? At the micropyle region of the ovule. Okay, at the micropyle region of the ovule. So this structure is what? We are calling it as what? Ovule. This structure is the ovule, we are saying. So at the micropyle region, what is being fertilized? Here, after the fusion of male gamete with the female gamete, what is formed? Zygote is formed. So where is the location of zygote now? It is at what? the micropyle region. So you have to remember, where is the zygote present in the ovule? It is present at the micropyle region. So here, let us say that this is the zygote. This is the zygote. Please remember, where is the zygote present? It is present at the micropyle region of the ovule. Micropyle region of the ovule, which is diploid. Which is diploid. And now, this zygote is this we are seeing now. This is the zygote. Let us say that this is the zygote. So what are the changes now which are undergone in the zygote? What is the changes that it is undergoing? Now the first change that this zygote undergoes is it produces a cellulosic wall. It produces a cellulose wall. So the same diagram I am showing here. Just imagine that this is the zygote now. This is the zygote. The same thing. This zygote is producing what now? A cellulose wall. They say that this cellulose wall is produced during unfavorable conditions, we say. Again, what is this unfavorable conditions? Please remember, we know that the zygote will develop into embryo before what? Before the zygote will be developing into embryo only after what? Only after what? After the formation of endosperm. If there is no endosperm, there will be no growth and development of this zygote, or fertilization to take place and form into an embryo. Please remember that. If fertilization fails, the endosperm will not be formed. The endosperm will not be formed. That is very important point. So here, simple point that you have to keep in mind is that before the embryo is formed, there is already the formation of what occurred? It is the endosperm that is formed. So here, again we are connecting to that. When the embryo is not formed completely, we say that it is unfavorable conditions. We say it as what? Unfavorable conditions. And immediately what is formed? A cellulose wall is formed around the diploid zygote. This is what? Okay, around the zygote what is formed now? Cellulose wall is formed. Okay, for a short period of time. Once there is formation of the endosperm, now this zygote, which is covered with what? Cellulose wall. Now once it is covered with cellulose wall, this zygote is called as oospore. Please remember this word, called as oospore. Very, very important word you have to keep in mind. That is what? When the zygote is covered by a cellulose wall, we are calling it as what? Oospore. We are calling it as oospore. Now we are going to call zygote as what? Oospore. Now this oospore now divides. Now this we will follow with the diagrams now. Now this oospore divides. It is dividing transversely. Transverse section of division will be taking place. Transverse section division will be taking place. And that too, the transverse section that is seen here will be unequal division. See here, we have to remember that it is undergoing unequal division. Okay, unequal division. So that is one more point you have to remember. The zygote is undergoing what type of division? Is it longitudinal division or a transverse division? It is transverse division. Okay, transverse section. Transversely it is divided. How is it producing the equal cells or unequal cells? It is producing unequal cells. It is producing unequal cells. That is very, very important. Now we said division. Division means what? Please remember, once the zygote is formed, until it forms the embryo or continuously from then on, this will be undergoing only mitosis. Please remember, all the embryo is formed by what division? Mitotic division only. Please remember, this is also an important point. The zygote, starting from the zygote until it forms the embryo, mature embryo, it is undergoing what? Mitosis. But here the first step, this oospore, simply we are calling it as what? Zygote, is undergoing what? Transverse section. Okay, transverse section. Whatever, is it equal division? No, it is unequal division. And that's why here, if you are seeing clearly, it is producing two cells. One is which is large in size and one which is small in size. See here now, one is large in size and one is small in size. Now, here in the very beginning we said that the zygote is present towards the micropyle region. Now, when it is dividing into unequal, okay, when it is undergoing unequal division, when the zygote is undergoing unequal division, now it is producing two cells. It is producing two cells called as what? Suspensor cell and embryo cell. Suspensor cell and embryo cell. So where is this suspensor cell and where is this embryo cell? We will see. So here what we are saying, there are two cells that are formed, suspensor cell and embryo cell. Here we have to remember that when the zygote, okay, undergoes unequal division, okay, transfers unequal division. What type of division we said? It is undergoing what? Mitosis, okay, it is undergoing mitosis division. Producing what? Two cells. Producing two cells now. Where are these two cells present? That's the question here now. These two cells are present at the micropyle region, because what we said, zygote is present at what? It is at the micropyle region, and it is starting now the division at micropyle region of the ovule only. But here we have to be very clear when we are talking about these two cells. Now see here, now I am talking about the embryo sac. Okay, if this is the embryo sac, let us say that this is what now? The micropyle region. Okay, micropyle region. Now here is the micropyle, means what? It is covered by what? Integuments. It is covered by integuments. This is the micropyle region of the ovule. Okay, micropyle region of the ovule. So here are the two cells that are formed when the zygote has undergone division. Okay, when the zygote has undergone division, two cells are formed. One cell and the other cell. Now see here, you can see very clearly that one cell is small and the other cell is large in size. I am talking about these two cells now here, which we have drawn here. Okay, so one is large and one is big. So one which is large is called as what we said in the diagram, suspensor cell. Okay, suspensor cell, which is towards which region? It is towards the basal cell, basal region. So we call it also as basal cell. We call it as basal cell. And one which is towards the water, what will be here? Or what is the end of this? Chalazal region we say, isn't it? Or where in the embryo sac, if you are seeing, antipodal cells will be there, isn't it? Or otherwise we are calling this as what? This region we will be calling it as what? Chalazal we are calling it as, isn't it? So the small cell which is towards the chalazal region, which is towards the chalazal region, we are calling it as what? Embryo cell. Okay, embryonal cell, embryo cell. Otherwise we are calling it in simple called as terminal cell. Okay, terminal cell. This is the terminal cell. Please remember this. Okay, please remember this. So it is clear now that once the zygote, okay, once the zygote undergoes transverse section, unequal division, it is producing two cells. One is large in size, one is small in size. The large cell is called as what? The suspensor cell. Otherwise we are calling it as in simple basal cell. And the cell which is small in size is called as what? Embryonal cell. Otherwise it is called as terminal cell. Terminal cell. So here are the two cells, their position exactly in the ovule. So the basal cell will be at the opening of the what? Micropyle region. Whereas the small cell is towards what? Towards the chalazal region or antipodal cells. So we are calling it as the terminal cell, which is the embryonal cell. Embryonal cell. So there are two cells that are formed. Basal cell, that is called as suspensor. Terminal cell, which is called as embryonal cell. Embryonal cell is towards the chalazal region, whereas the suspensor cell is towards the micropyle region. Micropyle region. So now we will see what is happening with the suspensor cell and what is happening with the embryo cell. What is happening with the suspensor cell and what is happening with the embryo cell. And we said what? Suspensor cell is towards the micropyle region, whereas the embryo cell is towards the chalazal region. So first we will look at the suspensor cell. Okay, suspensor cell. Now this suspensor cell, okay, this suspensor cell, I'm going to just show you this diagram in an inverted way in an ovule. Okay, now here is the suspensor cell. Okay, here is the suspensor cell, and the small cell, what we said, it is the embryonal cell. Okay, it is the embryonal cell. Okay, so this, we are talking about now this suspensor cell. Okay, suspensor cell. This suspensor cell undergoes transverse division or mitotic division only. Transverse division for few times. For few times it will be undergoing transverse section division, means only this cell. Okay, only this cell, suspensor cell only. Okay, we are talking about now this suspensor cell, not the embryonal cell. So here this suspensor cell, when it divides for few times, it will be forming few cells. Few cells means it may be forming 6 to 10 cells. It may be forming 6 to 10 cells undergoing transverse division. Remember that. What type of division it is undergoing? Very, very important thing is what? Transverse division. Transverse division. And this is with in the case of what? Suspensor cell. So suspensor cell has divided few times and formed about 6 to 10 cells it will be formed. But at the end, what is this cell that we are talking about? We are not talking about this cell is the embryonal cell. This cell is the embryonal cell. So the basal cell is dividing, which is towards the micropyle region. That is nothing but suspensor cell. Now when it divides, remember it is pushing the embryo. This is what we said. The embryo, the same cell. This is the embryo. Okay. It is pushing as the suspensor cell is multiplying. Okay. Undergoing transverse division, increasing in number of cells, it is pushing this embryo cell deep inside into the endosperm that is present in the embryo sac. In the embryo sac now. So now the question will be asked: what is the function of the suspensor cell? The function is to push the embryo into the endosperm or deep inside or towards the center of the embryo sac. Towards the center of the embryo sac. So here we can say now this is the embryo sac. And here we started from here. So this is the suspensor cell which has undergone transverse division and pushed the embryo towards the center now. Towards the center. And here we are saying like this. Okay. Here we are saying like this, that this is what, okay, is the embryo. Okay. This is what is how it is formed. This is the ovule. Now suspensor has divided and formed into mini cells, pushing the embryo towards the center. After pushing it towards the center now, this structure, okay, will be called as the proembryo. We call it as proembryo. We call it as, okay, we are calling it as proembryo. We are calling it as the proembryo. So what is proembryo? It is from the time the egg is fertilized and how the cells are formed until it forms the tissues and organs. Tissues and organs. The two cell structure with what? Suspensor and embryo. Until it forms what? All the important parts of the, okay, embryo. It is called as proembryo. So here, if you see the suspensor, okay, let us say this is completely the suspensor. But if you are closely observing here, in the suspensor, there are two cells which we are going to talk about. The one which is extreme to the basal end, this, and also this. This one cell of the suspensor, the cell which is towards the basal end, okay, will be swollen in size, means it is enlarged in size, and this cell is called as haustorium. We call it as, okay, haustorium. We call this as haustorium. What is the function of this haustorium? It absorbs the nourishment from the endosperm. It absorbs the nourishment from the endosperm for the developing embryo. Now, at the same time, what we said, this cell as the embryo. This is the embryo now. And just adjacent to the embryo, there is another cell of the suspensor only. The cell which is adjacent to the embryo, okay, will be called as what now? Hypophysis. We are calling it as hypophysis. Okay, we call it as the hypophysis. These two are again very important, hypophysis and haustorium. We already said what is the function of haustorium, means what? Provides the nourishment, absorbing all the nourishment from the endosperm and supplies it to the embryo. But this hypophysis is having a very important function. That is, it is this hypophysis which will be, okay, which will be responsible for the growth of, or from which the root cap and root tip will be formed of the root. Okay, so hypophysis is playing a crucial role for what? In the development of radicle. Radicle means what? It is nothing but the root system. It is nothing but the root system. So hypophysis is it is one of the cell of what? Suspensor. Adjacent to what? Embryo. And it is important for what? For the formation of root cap and also root tip. Okay. Means what? Hypophysis is playing an important role for the formation of radicle. See, I said here root cap and root tip, but not the complete root. Not the complete root. That we have to remember. So, it is playing an important role for the formation of radicle, especially the root cap and the root tip. And now, the embryo. This is how the suspensor has pushed the embryo towards the center of the embryo sac, and this embryo, okay, will now undergo division. See, till now we said it is undergoing transverse. Zygote has undergone transverse division, and the suspensor cell also have undergone transverse division. But now here, when we talk about the embryo, let me take this as the embryonic cell. This is the embryonal cell. It will be undergoing two longitudinal divisions. First division. So when it is undergoing one longitudinal division, it is forming into how many cells now? 2 cells. There are 2 cells now formed. Please remember, the embryo is undergoing 2 longitudinal divisions, and 1 transverse section division. So once it undergoes 2 divisions, okay, 2 cells are formed, and immediately again this is again undergoing how many now divisions? Another second lateral division. So which means how many cells are there now? 1, 2, 3, 4 cells are there. 4 cells are formed. Or the same thing, let us put it like this. There are 4 cells now. Okay, there are 4 cells. 1, 2, 3 and 4 cells. So here are those 4 cells we are seeing in the diagram. This is only in a schematic way, in a diagrammatic form we are seeing. Okay, so these 4 cells are formed by what? It is by 2 longitudinal sections and 1 transverse section. Okay, sorry, 2 longitudinal divisions it will undergo. So once it undergoes 2 longitudinal divisions, how many cells are formed? 4 cells. So this structure, in some cases we also call it as quadrant. Okay, we call it as quadrant stage. Okay, quadrant we call it as, when it is showing 4 cells. By undergoing what? 2 longitudinal sections. The same thing with these 4 will be undergoing. See here now, these 4 cells. Okay, these 4 cells. Okay, so here we are seeing 4 cells. These 4 cells are formed by what? 2 longitudinal section cuttings. One cell has undergone 2 longitudinal section cuttings and formed 4 cells. And now these 4 cells together will undergo 1 transverse section cutting. 1 transversely it undergoes division. Now it is in this way it is divided. So totally how many cells will be formed now? There will be 1, 2, 3, 4, 5, 6, 7, 8. There are 8 cells formed. So this structure here it is seen. We call this as octant. Okay, we call it as octant stage. Okay, this is octant stage we call it as. Here are 8 cells that are shown here. 1, 2, 3, 4, 5, 6, 7 and 8. There are 8 cells. So totally we call it as now octant. Previous one is what? Quadrant we said. Previous one. This is called as quadrant structure. And this is called as the octant structure. Now all those 4 cells are now formed. 8 cells are formed. Now if you are seeing here, the 8 cells are arranged in such a way that they are as 2 layers. They are formed as 2 layers. Which means we also call this as 2 ties. Okay, in the form of ties we call T-I-E-R-S. 2 ties. Ties means what now? Layers. 2 ties. Then when we say that it is 2 ties, very important point now is that what are those cells which are there arranged in 2 layers will be formed. Okay, into what layers they will be formed. So here, if you are seeing the 8 cells of the embryo now, okay, undergoing how many divisions? 2 longitudinal divisions and 1 transverse division gives rise to 8 cells. Octant stage. This is what we are talking about. Octant stage. Now these 8 cells are arranged as what? 2 layers we said. Which means we are also using another word, ties. T-I-E-R-S. Ties we are calling it as. Now the 4 cells which are above, okay, as the first layer, top layer, we call it as what? Epibasal. Okay, we call it as epibasal we call it as. And those which are adjacent to the hypophysis or suspensor, okay, hypophysis. And these cells are called as hypobasal. Okay, hypobasal. Okay, 2 ties are arranged as 2 layers. Epibasal, hypobasal. Now this epibasal, okay, all these will undergo, they not only has 4 cells, these 4 cells now will undergo repeated division. When they undergo repeated division, it is these cells which will be giving rise to the plumule, and as well as the cotyledons, So here, that's the point we have to keep in mind from the epibasal cells. Hypobasal, the other 4 cells will undergo repeated division, and this is responsible for what? For the formation of the radicle. Radicals means what? Root system. Please remember, when we are talking about the radicle that is formed from the hypobasal, we also should remember that hypophysis is also helping in formation of what? Or part of what? Radicle. Because what we said, hypophysis is responsible for what? For the formation of root cap and also root tip. Root cap and root tip. Hypophysis will be helping out. So this is how the embryo will be changing slowly. So from this stage, it is now slowly changing into dividing now. All these cells will repeatedly undergo division now. Now another point that we have to keep in mind. We will now look at how it is forming into dermatogen, okay, progambium, and also ground meristem. Okay, how they are formed. So now all those 8 cells, octant stage we say, okay, 8 cells. All these 8 cells will now undergo the periclinal division. That's very important word. Okay, periclinal division. Very important. You have to remember the types of divisions that are taking place starting from the zygote. Okay. Now this one. Okay. Now when it is showing, when the embryo development is at octant stage, this structure is undergoing what type of division? Means periclinal division. Means the 8 cells, okay, 8 cells of embryo. Let us make it like this. 8 cells of embryo is undergoing what of division? Periclinal division, adding many cells. See here, periclinal means what? If this is the cell, okay, if this is one cell, second cell, okay, these are the 2 cells. Whenever we come across periclinal, please remember, due to this cell division that is called as periclinal, it will undergo like this, adding the cells as layers. So the same thing will be appearing how now? 2 cells will be there here like this, it will be forming. Again, if it is undergoing division, again 4 layers will be coming up like that, it will be forming. 4 layers will be coming up. So here, when the 8 cells embryo, that is octant, when it is undergoing periclinal division, it forms as layers of cells. Outer layer and inner cells will be there. Outer layer of this embryo will be called as dermatogen. So see here, 8 cells of embryo are undergoing periclinal division, and the outer layer, okay, So outer layer will be called as what now? The dermatogen. Okay, will be called as the dermatogen. Otherwise, we also call it as protoderm. It is this dermatogen which will be helping in formation of the epidermis. Okay, Please remember that. So from the dermatogen layer, what is formed? Epidermis is formed as the outermost layer. Inner cells. See here, if you are seeing, when the octant is undergoing, when this octant cells, 8 cells are undergoing periclinal division, they are forming into many cells. Here we can see in this diagram very clearly. Many cells are formed. Outer cells are called as what? Dermatogen. And whereas the inner cells, okay, are as the ground tissue. Okay, let us say here, this is the first one, second one is ground tissue, and innermost is procambium. There are 3 different types of cells initially that are formed in the globular embryo. Why we are called this structure as globular embryo? Because it is appearing like a globe, like ball of cells. So dermatogen, outermost layer, is giving rise to the epidermis. Then the second one is the ground meristem. Okay, ground meristem. This ground meristem will be giving rise, okay, will be giving rise to the other cells, will be giving rise to the other cells. Other cells called as what? Cortex and pith. Cortex and pith will be formed from the ground meristem. And the last one, as we have seen, the innermost cells called as what? Procambium. Okay, if you are seeing the third one, let us say this is the first one, second one, and third one I am writing here, the procambium. Okay, procambium. And this procambium will help in formation of the steel or vascular structures. Okay, vascular structures. That's what we have to remember when we talk about how this octant is dividing. By what division? Periclinal division. By what division? Periclinal division, adding many cells. So if you are seeing what we said, outer layer is dermatogen, also known as protoderm, which is giving rise to the epidermis. Inner second layer is what? Ground meristem may be there, which will be giving rise to cortex and pith. And procambium will be giving rise to the steel or vascular strand. Okay, vascular strand. These are all will be seen when the 8-cell embryo is undergoing periclinal division. When it is undergoing periclinal division. And now this structure, here if you are seeing, this structure is called as the globular structure. Okay, it is called as the globular structure. And slowly this globular structure develops and changes into another simple structure called as heart-shaped structure. It is changing into heart-shaped structure. Okay, and changes into heart-shaped structure. This is another one you have to remember, heart-shaped structure. And this heart-shaped structure now continuously undergoes mitotic division, forming and giving and developing into mature embryo. Forming and developing into a mature embryo, where the mature embryo will be showing the different parts. Mature embryo will be showing the different parts. One with the two cotyledons, there will be two cotyledons, and faintly, very faintly we can see here the plumule. Plumule is what? Future shoot. Future shoot. And we are also seeing the radicle. Radicle. And this radicle, already we said that when this octant is dividing, it is forming into two layers, we said two tiles. Two tiles. The upper layer will be giving rise to what? The shoot system, plumule and cotyledons. Lower layer, the four cells as the second layer, it is giving rise to what? Radicle, along with the help of what we said, hypophysis, which helps in formation of what? The root tip and root cap. Root tip and root cap. So this is how the complete growth and development of the embryo will be taking place. So in quickly if you see here, now the zygote undergoes what? Transverse section, and it is which is unequal, forming two cells, and the suspensor cell is towards the micropyle region, whereas the embryo cell is towards the chalazal region. This is called as basal cell, and this is called embryo cell is called as terminal cell. And the starting now suspensor cell undergoes repeated division, where it is forming into 6 to 10 cells for few times. What type of division it will undergo? Transverse section division. After undergoing transverse section division, now the embryo will undergo 2 lateral section division and 1 transverse section division, forming 8 cells here. If it is 2 lateral section, it is forming 4 cells. We are calling it as what? Quadrant. Quadrant we call it as. One of the suspensor cell towards the basal end is called as posterior cell, which is absorbing the nourishment and supplies to the growing or developing embryo. And one cell of the suspensor, which is just adjacent to the embryo, called as what? Hypophysis, which is helping in formation of what? Root cap and root tip. Root cap and root tip of the root will be formed from the hypophysis. And now what we said? The embryo is undergoing division now. Okay, it is undergoing another transverse division, because we said 4 cells. So these 4 cells, when they undergo transverse division, 8 cells are formed. Forming as 2 layers, we said hypobasal and epibasal, as 4 cells and other 4 cells. So 4 cells means what? Those which are towards the chalazal region will be called as what? Epibasal. Those which are adjacent to the hypophysis are called as hypobasal. epibasal we said. Epibasal, hypobasal. Now epibasal is giving rise to what? Plumule and cotyledons. Hypobasal will be giving rise to what? Radicle. Along with hypophysis, root tip and root cap. Now that's what we said. And the same octant is undergoing what type of division? Periclinal division. Those 8 cells are undergoing periclinal division. Giving rise to what? Dermatogen, ground meristem and prokaryote. Dermatogen also called as protoderm, which is giving rise to epidermis. Ground meristem is giving rise to cortex and pith. Prokaryote will be giving rise to stele or vascular strand we said. And now this is the globular shape, just like a globule of cells, just like a ball of cells, which are undergoing repeated division and slowly they change into heart shape. And now this heart shape again much more changes it undergoes, giving rise to 2 cotyledons if it is in dicot plants. 2 cotyledons, and at the center of the axis of this embryo we will be seeing the plumule at the tip, at one tip, and at the base we are seeing the formation of the radicle, means root, along with the hypophysis which helps in formation of root cap and root tip. This is how the embryo formation will be taking place, which we are calling it as what? Embryogeny. Embryogeny. We will see in the next class how a typical dicot embryo will be formed and monocot embryo will be formed. But this part is very important for your entrance exams. Thank you so much.